So we're going to be doing several problems that involves conservation of energy. We have a setup where we've got a ball at the top of a hill, the height is given, the mass of the ball is given, and we have several locations A, B, C, D, and E. So the first question is to find the gravitational potential energy at point A. So we're going to set up our 4 steps gravitational potential energy, sometimes known as EG, is going to be our unknown. We know the height is 20 meters. We know that gravity is 9.8 meters per second squared. And we know that the mass of the ball is 30 kilograms. And that's our first step. We've listed out all of our knowns and unknowns. So knowing this, we want to find GPE, and we've got several factors here, several variables. And the equation that best fits this is GPE, or EG, is equal to mgh, mass times gravity times height. So we plug those numbers in. GPE is equal to the mass, which is 30 kilograms, gravity, 9.8 meters per second squared, and the height, 20 meters. So that's our third step, plugging in the numbers. When we do the actual math, we find out that GPE is equal to 5,880, and all those units together come out to be joules. And that is our final answer for this question, so we'll put our box around it. Next, we have to find the kinetic energy at point A. We can work out the entire formula, and we find out that because it is not moving, this is just something that you should know at this point. The kinetic energy of an unmoving object is going to be 0 joules. The total mechanical energy at point A, total mechanical energy, is equal to any kinetic energy plus any potential energy. And that includes elastic energy, or in this case, gravitational energy. So what we know is the kinetic energy is 0, and the potential energy is 5,880. And so the total mechanical energy at this point is just our 5,880 joules. We didn't really do much calculation there, but we're still going to put a box around it anyway. Now we need to know the GPE, the gravitational potential energy at point B. Let's go back up here. At point B is at the very bottom of the hill. That means that there is 0 height. And so hopefully we don't have to work out this entire thing to find out that when you multiply anything times 0 height, the answer will be 0. So let me scroll back down here. And so since h is equal to 0 meters, that means that the GPE is equal to 0 joules. Okay. The KE at point B, well, in this case, I think I'm going to set it up as a 4-step equation because we have our unknown, what we're trying to solve for. We know that our total mechanical energy is equal to 5,880 joules. And we know that our gravitational potential energy is equal to 0 joules. Okay, so we use this relationship, total mechanical energy is equal to KE plus PE. We plug in our numbers. 5,880 joules is equal to KE, we don't know that one, plus our potential energy, which is gravitational potential energy, which is 0 joules. And now all we have to do is solve. Well, this one's fairly easy. We know that the kinetic energy is going to be equal to 5,880 joules. Now we didn't have to do all that work because we know that as potential energy decreases, kinetic energy will have to increase because the total mechanical energy will always stay the same. So in this case, the potential energy went down to 0, and so that means the kinetic energy had to go all the way up to whatever the total mechanical energy is. Now we're going to use that information to find the speed of the ball at point B. So let's just go back up and recap. Point B is down here at the bottom of the hill, and we need to find the speed. So to do that, there's only one equation that we know of that involves speed or velocity, and we're going to end up using that. So that equation, we need to know the kinetic energy, which we just recently found, 5,880 joules. The mass of the ball, 30 kilograms. And we would like to know velocity. So the only equation that involves that velocity is this one. K equals 1/2 mv squared. And now you can plug in the numbers here and solve for velocity if you like, but you may have already done it where you find out that the velocity is the square root of 2 times the kinetic energy divided by the mass. So the velocity here will be the square root of 2 times 5,880 joules divided by 30 kilograms. And when we solve this, you have to be careful. Remember to take the square root, okay? Square root. So I'm going to put a little star here to remind us. Square root, okay? Because there are so many times I've seen where we get to this point and you solve the inside of the square root, but we forget to take the square root. So when we do this, we end up with our answer of 19.8 meters per second. That is how fast that ball is rolling at the bottom of the hill.